Here's number 3 from the Chapter 5 AP packet. The graph of the velocity, v of t, of a car traveling on a straight road is shown below. A table of the values of v of t in 5-second intervals is shown also. During what intervals is the acceleration positive? I can't say anything about acceleration since nothing was given to me here as far as evidence-wise about acceleration. But I was given velocity, and the link between velocity and acceleration is that acceleration is equal to the derivative velocity. So if acceleration is positive, then v prime is positive. If v prime is positive, that means velocity is increasing. If I look at where does this, in this graph, where is velocity increasing? It's during those highlighted sections. So then I would have from 0 to 35 and from 45 to 50. Approximate the distance traveled from 0 to 30 of the right Riemann sum with 6 subintervals of equal length. Show the computations on each of your solutions using the correct units. Explain the meaning of this integral. So, if I'm looking at 6 subintervals of equal length, I need to find delta t. The formula is, again, b minus a over n, which would be 30 minus 0, and then n, since it's 6 subintervals, divided by 6, gives me 5. Since I'm using a right Riemann sum, I'm not going to start at 0. I'm actually going to start one step over. So this is 5 times, and then this would be the velocity at 5, the velocity at 10, the velocity at 15, the velocity at 20, the velocity at 25, and then the velocity at 30. Now you don't have to write this all out in terms of velocity, but I did so I can show you that I start at the 5 and I have 1, 2, 3, 4, 5, 6 intervals. If I use a table and I plug in the numbers from the table, they will be 12 plus 20 plus 30 plus 70, 55 plus 70 plus 78, which gives me a total of 1,325. Using correct units, explain the meaning of this. Well, if I'm ever multiplying time by velocity, that should give me distance, or in this case, it could also be displacement. So this is feet. For the interval t equals 0 to t equals 30 seconds, the car has traveled 1,325 feet. Is your answer from this should say part B, an over or under approximation of this integral? Justify your reasoning. If I'm comparing a right Riemann sum and trying to figure out if it's over or under, I want to determine whether the function that's inside the integral is increasing or decreasing. If I look from 0 to 30, from 0 to 30, this function is increasing. So velocity is increasing. So since v of t is increasing for the interval 0 to 30, a right Riemann sum will be, and now I am going to draw this just to make sure, increasing right Riemann sum, it's an over approximation, will be an over approximation. D, approximate the integral from 0 to 50 of v of t using the left Riemann sum. So it's very similar to part B, except now the interval is wider and I have 5 subintervals. Once again, delta t equals b minus a over n, so 50 minus 0 divided by 5 gives me 10. So I can put a 10 on the outside, but then since it's a left Riemann sum, if the first rectangle stretches from here to here, a left Riemann sum would be using the 0. And then the next one would be using 20, 55, 78, 75, and then the 72 would have to be on the right side. So if I write this all out, it would be 10 times 0 plus 20 plus 55 plus 78 plus 75, which comes out to be 2,280 feet. And your explanation would be very, very similar to what you did in part B. The car has traveled 2,280 feet over the interval of 0 to 50 seconds. Don't forget your units. If you forget units, because it does specify you want units, you will not get all the points.